Okay, everybody, I'm back. You should be adding to your notes that had decimals and percents at the top. On the bottom, multipliers and exponential growth. I'm going to try to go pretty quickly, so if you need to pause, do, but I need to make this a quick video. All right, exponential growth is the same as geometric, except that it's continuous. It still grows by multiplying, but we don't just have individual terms the way we do in series. So when we have growth, we often have percentages of growth, and we have to find the multiplier. It'll tell us the percent growth, but we have to figure out what to multiply by. If it's growth, we take 100% because we start with whatever we've got. We start with all of it, 100%, and then we add to it. So we add the percent growth. Divide by 100 to make it a decimal, as we learned before, and that gives us our growth multiplier. Same thing if you get decay, decrease, or this other word down here, depreciation. They all mean about the same thing. We're going to take the 100%, and we subtract because we're taking away a portion of it. So we subtract it from 100. Then we divide that number by 100 to get our decay multiplier. Do use the parentheses if you put it in the calculator all at once so that the whole thing is divided by 100. Okay, so for our exponential growth formula, we have it right here, y equals a times b to the x, where a is your initial value. Similar to sequence, except that it's not term 1. In this case, initial value is when it's 0, so it does change things a little bit. B is your multiplier, and x is your variable, usually some kind of time. Years, minutes, even millennia could pass for this exponential growth, but x is however much time or something else maybe that has passed. Okay. Let's look at some examples. If a population starts at 300 and grows by 4%, well, if we want to find our multiplier, we would take 100 plus 4, all in percents, and then we divide those by 100 to get our multiplier. Put that in the calculator and you get 1.04. Notice that number is bigger than 1 because it's growing. If we want to put that into the equation, y equals our initial value, 300, times our multiplier, which we just found to be 1.04, to the power x. If I were to ask you, well, okay, how much do you have after 10 years? Then we'd simply fill in 10 for x. Quick example, so y equals 300. 1.04 to the, 1.04 to the power of 10 would give us how much there is in 10 years. And I believe when I stick that in my calculator, I get 444. If you don't know how to get it in the calculator, ask a teammate. Somebody in here will know. All right, next one. Car's purchase value. So y equals $15,000 for the car. And it depreciates. Depreciate means go down. So to get our multiplier, we're going to do 100 minus 12 over 100 again because we're changing it to a decimal. Type that in your calculator and you get 0.88. So our multiplier is 0.88. Notice that that is less than 1. Less than 1 means it is getting smaller when we multiply by something less than 1, just like multiplying by fractions. All right, and then a sample radioactive material, 500 decaying at 23. So if it decays, that's still going to be 100 minus 23, all over 100 again to change it to a decimal. That gives me 0.77. My multiplier then is 0.77, and if I wrote it, 500 times 0.77 to the power x. Last thing, it's not really typed on these notes, but I know it's in your work, is what if you had an equation? Suppose I gave you this equation. And whatever it referred to, you should be able to tell me that it's growth. Remember that we added it into 100%, so if we want to know how much the growth is, we just take off the 100%. Well, the 100% just shows up as that 1 in the decimal. So our growth would be 31%. And if we needed our initial value, it's going to be this number here. So we have initial value of 23. Whatever the problem tells you. Very, very quickly, let's look at one that's decay. Suppose we had that equation, 2 times 0.62 to the power x. We know it's decay because it's less than 1. If we need to know how much it's decaying, let's just do 100 minus this number is a percent. If I multiply times 100, I get 62%. So 100 minus 62, which would give me 38. So that's telling me I have 38% decay with an initial value of 2. All right, that's enough for the notes. You guys have a worksheet. If you need any help, please see Ms. Rhodes or Mr. Radicke. And I will be back tomorrow to help you guys finish up this 9 weeks. Have a great day.